chlorine solution is poured over the surface of a rectangular swimming pool that is 25 meters long, 10 meters wide, and 2 meters deep everywhere. Before the circulating pumps in the pool are turned on, it is discovered that the density of the chlorine solution at a height h meters above the bottom of the pool is given by rho of h equals 100 h grams per cubic meter. Find the total mass of chlorine in grams in the pool. Okay, so I've done my best job of drawing a 3D pool here with some dotted lines for the parts that are farthest away from us. But I'll just point out here that this space right here is the top of the pool, and then down here is the bottom of the pool. Okay, so we are looking for total mass, and so I think what we want to do is draw a slice or a slab here where we're grabbing water molecules that have roughly the same density of chlorine. And so I think there's two natural ways to slice. You could either slice like this way, like going down to the bottom of the pool and then across the bottom of the pool and then back up, or you could slice perpendicular to that. So that would be, you know, like coming this way. Did I go too far? I think I did. Nope, didn't go too far. So coming this way and then back here and then coming back out this way and then over here. And so the first thing that I drew involves grabbing water molecules at the top and then also grabbing water molecules at the bottom. But the point is that this 100H is telling you that if your height changes, like depending on how far you are from the bottom of the pool, then the density of the water, well, the density of chlorine could change quite a bit. So you don't want to grab things with wildly different values of H. And I have with this slice that's drawn here. I've grabbed some stuff where H is equal to 0, or we're at the bottom of the pool, but I've also grabbed some stuff where H is equal to, however deep this thing is, 2 meters at the top of the pool. That's no good. So we don't want to draw that kind of slice. We want to draw a slice perpendicular to that. So we're going to go from here to here, and then we're going to come out this way. That is poor. We're going to come out this way. It's better, but not great. We're going to come out this way, and then we're going to go back behind here. And then, gang, I'm having some real trouble with this. I think that's it. Okay, so imagine giving this slice of water a little bit of thickness. I've just drawn a two-dimensional thing. There's no chance I'm going to take any risk at drawing another copy of this slightly above or below it, but give that slab of water a tiny bit of thickness. And we know that the mass of a slab is equal to the volume of the slab times the density of the slab. Okay, so the volume, well, again, it's a blue rectangle right now, but give it a little bit of thickness. So it's a shoebox. So length times width times height times density. All right, so let's start labeling some things here. We know that this pool is 25 meters long. So that's this side right here, 25. And then it is 10 meters wide. So I think that's this blue side over here. That's a 10. And then the thickness, sorry, it's 2 meters deep. So that's the whole, I'm going to mark it over here in green, different colors. That whole thing is 2, but that 2 is not relevant for the specific blue slab that we've drawn. But let's start labeling or filling in our labels here. So for our blue slab, what's the length? Well, it's always 25, no matter where this slab is as you slide it up and down the pool. And the width of our blue slab is always 10, but the height of our blue slab is not 2. The height is just whatever tiny thickness we give it. But again, I didn't draw it, but I feel like delta H would be a really good name for that tiny bit of thickness. And then the density of the chlorine everywhere is given by our formula 100H. Okay, so I think we're good to go here. Let's just crunch some of these numbers together. So 250 with another couple of zeros at the end. 25,000 H delta H. So that is the mass of one slab, mass of the chlorine in one slab. We'll convert that into the mass of all the slabs. So it's going to become a sigma 25,000. Every H becomes H sub I. Delta H stays as it is. I going from 1 to n. And then what we really want to do is let the number of slices go to infinity. So we do that here. And then we're going to convert that to an integral. It's in exactly the right form for an integral. integral. Okay, so this is the integral from 0 to 2. That's the values of h. And then we just go 25,000. hi goes back to being an h. Delta h becomes a dh. And all of a sudden, we've got a very simple integral to evaluate. Okay, so here we go. 25,000 h squared divided by 2, going between 0 and 2. So that is equal to, so the 25,000 over 2 reduces to 12,500. And then the h squared is really a 2 squared. And then minus, then the 0 is also getting squared. I'll put the 25,000 on the outside of the whole thing. Sorry, 12,500 on the outside of the whole thing. So anyway, 4 times 12,500 is 50,000. And this is a mass, it is grams.